Right, hello there, my name's Paul and I'm here to introduce you to the wonderful world of imaginary numbers. Now, you may have heard of these described as made-up numbers because they are made up. They're not proper numbers. They don't exist. You may have heard them referred to as magic numbers because with them you can do what seems to be impossible in ordinary mathematics. But I prefer the more technical term imaginary numbers. And this is a very simple introduction to them. Let's start off with what we know about mathematics. We know what numbers are, the proper numbers. They're the counting numbers, 1, 2, 3, 4, 5, and so on. And basically that's what numbers are, stuff you can count with. I'm sure you're all familiar with the well-known proverb, if you can't count sheep with it, it's naught to do with numbers. And we all say amen to that. There is one honourable exception, though, that I think has found acceptance in recent times, and that's the number 0. Now, you can't count sheep with it, true, but, well, it sort of represents a number of sheep. 3 represents 3 sheep in a field, but 0 represents an empty field, no sheep at all. I know you can't count no sheep because you start counting at 1, but, well, it sort of works. And I think 0 has generally been accepted as a proper number alongside the others. And with these proper numbers, you can do mathematics. And mathematics is very simple. All you do is take one number and another number and add them together. That's it. So, for example, 2 plus 3 equals 5. And you may well have been shown how to do this using the familiar number line. Here we are, 1, 2, 3, 4, 5, 6, 7, and so on. There's no end to it, you keep going. But you can use this to do the calculations of 2 plus 3. You start with a 2. You've all been shown how to do this at school. You count along 1, 2, 3, and there you've reached 5. Dead easy. You could do it the other way around. If the sum was 2 plus what equals 5, what's my finger covering up? Well, you start at 2, you count until you get to 5. 1, 2, 3, we've reached 5, so the answer's 3. All very simple stuff. The meat and drink of mathematics, and in fact, this pretty much is the sum of mathematics. That's all that people do with it. However, mathematics has a failure because there are some sums under this system that are impossible. What about this one? 5 plus what equals 2? And straight away you think, obviously, there is no answer. You start at 5 on the number line, you keep counting, you can count 1, you can count 2, you can count 3, you can count as far as you like. You're never going to get to 2. This has no solution. So most mathematicians just throw up their hands in despair and say, well, okay, we just have to ignore this sort of sum. But some mathematicians say, what if we made up a number? What if we were able to get a solution to this? This is where imaginary numbers come in. Imagine that there is a number called m. We'll call it m for made up, magic, imaginary. And it has this property. 1 plus m equals 0. Yeah, I know there is no such number. I know if you start with 1 sheep, you can't add more sheep and get 0. Okay, it's made up, I admit that. But we'll assume it exists. And we'll, if we're going to make it up, let's assume it obeys all the normal laws of mathematics. Where does that leave us? Well, I'm going to pin that here because that's an equation we're going to keep coming back to. Remember, 1 plus m equals 0. What can we do with that? Well, let's just remind you of a couple of basic rules of mathematics. Okay, 2 plus 3 is equal to 3 plus 2. Again, familiar stuff. If you've got 2 sheep in one field, 3 sheep in another field, it doesn't matter whether you add the 3 to the 2 or the 2 to the 3. You'll get the same number. Okay? Another familiar principle of mathematics is that it doesn't matter what order you add things up. 2 plus 3 and then plus 4 is the same as 2 plus 3 plus 4. And again, you can work this out yourself if you just imagine 3 lots of sheep in 3 fields. Doesn't matter what order you add them up. So you don't have to put the brackets in. You can just write it as 2 plus 3 plus 4, or indeed 4 plus 2 plus 3. You can swap the order around. That's important when we come to doing our sums with imaginary numbers. So just reminding you of your basic maths. Okay, here we are. How can we solve our problem then? Do you remember? 5 plus what equals 2? Well, let's start with the equation we've got. I've lost it, it's come off. There we are. My equation. 1 plus m equals 0. Let's start with that. Now, add 2 to both sides. And if that's equal to that, well, 2 plus that is equal to 2 plus that. So, 2 plus 1 plus m equals 2 plus 0. And I've simplified that. The 2 plus 1 makes 3 plus m equals 2. Now that's not bad. We're part way there. That's the 2 there. There's a 2 here. We're part way there, but 3 plus m, that's not, we want 5 plus something. Okay, so here's the clever bit. We're going to add 0 to both sides. Where does that get us, you say? Well, remember, 1 plus m is equal to 0. So we're going to add 1 plus m to this side and 0 to that side. Okay, and what we get is 1 plus m plus 3 plus m is 2 plus 0. We can simplify that by adding the 1 and the 3 together. 4 plus m equals 2, getting us a bit closer. And then we do it again. 1 plus m plus 4 plus m, 2 plus 0. Put the 1 and the 4 together, and lo and behold, 5 plus m plus m plus m equals 2. We've got an answer. 5 plus what equals 2? M plus m plus m. Imaginary numbers allow us to do the impossible and to answer sums which otherwise we couldn't. However, that looks a bit clumsy. Is there a simpler way? Well, if you've done advanced mathematics at school, you will have come across a new kind of notation that's called Lotzer. And you know how to add sums together, but it's really just a simpler way of writing things out. It's just notation, that's all. 2 plus 2 plus 2 equals 3 lots of 2. And that's how we write it in mathematics. 3 lots of 2. And all it means is we've written it out 3 times. 2 plus 2 plus 2. If it was 4 lots of 2, it would be 2 plus 2 plus 2 plus 2. Okay? You get the idea. You may have even done this, as I say, if you've taken an advanced mathematics course. So, we can simplify this a little bit. 5 plus m plus m plus m. Well, let's write that as 3 lots of m. And we've got our answer. 5 plus 3 lots of m equals 2. We've found an answer. 3 lots of m. The amazing thing is, we started off with one assumption, that a number existed that satisfied 1 plus m equals 0. And we said it was a made-up number, but we've not made up just one number. We've actually made up m and 3 lots of m. And if we'd done other sums, we'd have discovered 2 lots of m, and 4 lots of m, and 5 lots of m, and 6 lots of m, and 7 lots of m, and so on. We've actually made up a whole lot of imaginary numbers. How exciting is that? But I'm not finished, because once we've got these numbers, we can start looking at other expressions and seeing if we can give meaning to those. What about m lots of 3? Well, that doesn't make sense. 2 lots of 3 is 3 plus 3. 4 lots of 3, 3 plus 3 plus 3 plus 3. How do you do it m times when m is a made-up number? Doesn't make any sense, does it? And what about this one? M lots of m. I mean, we don't know how many sheep m sheep is, and how to do it m numbers at a time. Well, you know, And yet, there's an answer. There's something that makes sense here. To explain this, let's just give you another little reminder of your advanced mathematics course, okay? You may have done this before. 3 lots of 4 is 4 plus 4 plus 4. You add them together, you get 12. 4 lots of 3 is 3 plus 3 plus 3 plus 3. And that also comes 12. So 3 lots of 4 is the same as 4 lots of 3. Coincidence? Well, maybe, maybe not. It turns out it's not a coincidence. This works for any two numbers. 2 lots of 7 is the same as 7 lots of 2. And there's an easy way to imagine why this is so. And if you go back to your sheep in your fields, except don't put them in fields. This time you put them in lines. Here we are. 3 lots of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You get them to line up neatly. Then what you do is imagine a trained lot of sheep that can march in formation, and you get them to do a sort of 90-degree wheel around like this. And look what we've got. We've got 3, 3, 3, 3, 4 lots of 3. And it's the same number of sheep. That proves 3 lots of 4 is 4 lots of 3. And as I say, it works for any two numbers. Here's another principle of advanced mathematics. 3 lots of 2 plus 4. 2 plus 4 plus 2 plus 4 plus 2 plus 4. But we can rearrange it. 2 plus 2 plus 2 plus 4 plus 4 plus 4, which is 3 lots of 2 plus 3 lots of 4. Okay? So we don't need to do the middle bit. We can just remember 3 lots of 2 plus 4 is 3 lots of 2 plus 3 lots of 4. Now, we'll be using those principles in a few moments. Let's see if we can make sense of a couple of these numbers. Right, m lots of 3. What's that? Very easy. Using the same principle as before, it's 3 lots of m. That's it. It's the number we've come across before. M lots of 3. We don't know what m is, but m lots of 3 is 3 lots of m. Wonderful. But what about this one? M lots of m. Well, the same trick won't work there, because if we put it the other way around, we've still got m lots of m. So we need to be a bit more creative. Let's have a look at this. Let's consider this expression. M lots of 1 plus m, 1 plus 1 plus m. M lots of that. Well, remember, 1 plus m equals 0. So this bit's 0. So it's m lots of 1 plus 0, which is m lots of 1. And that's just m. I've missed a step here. It's m lots of 1 is the same as 1 lot of m. Missed an important step there. But 1 lot of m is m. Okay. But there's another way of evaluating this expression. Okay. And that is m lots of 1 plus 1 plus m is m lots of 1 plus m lots of 1 plus m lots of m. And here I have remembered to do this stage. M lots of 1 is the same as 1 lot of m plus 1 lot of m plus m lots of m. And 1 lot of m is m plus m lots of m. So we've got two expressions here that are just different ways of evaluating the same expression. So they are the same. We need a new page now. We need to go on to... here we are. Right. So we've got one expression, m plus m lots of m equals m. It's the other expression, m. Right, we've got this. Now, add 1 to each side. 1 plus m plus m plus m lots of m equals 1 plus m. The 1 plus m is, you know this by now, say it with me, 1 plus m equals 0. So that's 0, and that's 0. Okay, we do it again. 1 plus m plus m plus m. And again, that's 0. That's 0. No, we've added 1. That's 1. It's 1. And what have we got here? Look at this. This is astounding. M lots of m equals 1. Now, if that doesn't excite you, you can paint me pink and call me Wilbur. We've no idea what m is. It's a made-up number. We've no idea what m lots of m is. And yet, it's 1. It's a normal, proper number. Wow! This is why imaginary numbers are such wonderful things. You can do all kinds of exciting stuff with them. Let me just share, if I can find a piece of paper amongst, here we are. Just a couple more things, just to finish off. Right, you know, let's back to the number line. 1, 2, 3, 4, 5, 6, etc. Let's get my pad, because otherwise that's going to be this. There we are. You'll be able to see me scrap paper on the other side. Otherwise, right, okay. Here's the number line. We've got all these new imaginary numbers, which we can also put in a nice line. And we've got the number 0. Well, that doesn't look very helpful, but there is a way of arranging this that might blow your mind. Take this line here, swing it round, and then stick a 0 in between the two, and what you get is this number, this number line here. Look at this number line with a 0 in the middle, the normal one you're used to, this side, and then all the M's and 2 lots of M and 3 lots of M going this way. And this, you can do all kinds of wonderful mathematics. Do you remember the puzzle we started with? We got 5 plus 3 lots of M equals 2. Let's do it the other way around to start with. 3 lots of M plus 5 equals 2. Look, 3 lots of M, there it is. And we count 1, 2, 3, 4, 5, 2. It works. The number line works. Even more astounding, 5 plus 3 lots of M equals 2. There's 5. We can't count any further up and get 2. But what happens if we count to the left? 1, 2, 3. 2. 3 lots of M means counting to the left, not to the right. It's astounding, isn't it? And that means with this number line and with the imaginary numbers, we can solve any equation of the form something plus something equals something. It completes mathematics. That's wonderful. However, when I say it completes mathematics, I should warn you, it doesn't complete advanced mathematics. When you add in lots of, it doesn't quite work. Look at this equation, and I'll leave you with this to ponder. 2 lots of something equals 1. 2 lots of what equals 1. Something plus the same thing equals a sheep. Crazy. No way. It doesn't work. This is something that mathematicians have been puzzling about for generations. And maybe one day somebody will be clever enough to end up finding a new number, inventing a new number that satisfies this. Who knows? Anything's possible. I mean, I can't really see how it can work. I mean, you know, this number line, I mean, it's pretty full as it is. I don't know where these new numbers are going to go. But there we go. Maybe one day. In the meantime, imaginary numbers. Wonderful things. Don't be frightened of them. They're made up. Yes, I know they're made up. But they're so useful. We should embrace them, because it's my suspicion that imaginary numbers are here to stay. Bye-bye.